Hello. In this video, I torture an AI to train it for total wipeout. The goal is simple. We have 3 obstacles: the balls, the sweeper, and the swing. The AI will have to learn from its mistakes to control his 40 muscles in a perfect manner, a bit like this.
Hello, I am under the water.
Welcome to training an AI for total wipeout. So how do you teach an AI to walk, run, and jump obstacles? This video is once again focused on reinforcement learning, a topic I already covered in my drone video. The basics of reinforcement learning is that an agent looks at his environment through sensors, takes actions, and gets a reward we define for him. The agent then trains on the memory of this sensor, action, reward triplets to find better actions. Reinforcement learning only works through careful environment shaping. We have to carefully define and iterate on what the agent sees, what he can do, and how we reward it. The agent should have all the necessary information to succeed in the environment, but not too many, as it would confuse him. Here, we give him his body positions and we draw rays from his eyes to the ground to help him know where the obstacles are. The agent also should have enough action space to succeed at his task, so we give him control over the 40 muscles on his body. Positive and negative rewards are given to the agent to explain the objective, but also give some pointers on which behaviors help towards the objective. Here, we'll start by giving the agent rewards for moving forward proportional to his speed. After defining all these, we can finally train. To excel at training, we train on these 8 parallel environments. In the beginning, the agents try random actions hoping to reach rewards. Training on such a complex task is a long process, so I'm gonna go to sleep and let him train for another 8 hours. Today I woke up with great hope. The training went well, the rewards increased a lot, but when I tested the agent, this happened. The agent learned that the best behavior was going off course and jumping as fast as he could into the abyss. So why did this happen? In AI, this is called a local optimum, when a neural network converges to an optimal behavior that is not the best behavior. Since the reward function is currently all about speed, he understood that going on those balls is hard and slows him down. Instead, jumping here is way faster and gets him more rewards. To fix this, we have to do an iteration of environment shaping. Action and input shaping are generally last resort. Since the neural network input and output sizes are fixed, changing them means either retraining the agent from scratch or doing some complicated brain surgery. An easy way to fix local optima is to change the rewards. Here, we'll punish the agent from going off course, as we think that staying in the center lane is the way to go. Now we wait for another night of sleep. This morning is a bit better. Our agent does stay on course this time and even passes a few balls, but he still falls before completing the course. When observing him, it seems that he gets a bit too ambitious with his speed and loses balance at the last obstacles. We need to slow him down, so we punish him for going too fast. Then another night of sleep, and finally we have an agent that completes the course. A few more nights of training for the other obstacles, and here are the results. Okay, bye.